All right, so once you've got your drop data done, you're going to come into the spreadsheet. Link is in the assignment, and you'll just go and fill in your data. So I have this set up where you just type in any yellow boxes that are there. You shouldn't have to mess with the other cells. They're all formulated for you. So I did this with, I had a little scale. So my first setup was 19.88 grams. That was my egg with, I forgot how many pennies in it, but I wrote down the mass. I had the scale. If you don't have a scale, off to the side, I've noted standard plastic egg is about 4.5 grams, and a penny, each penny is 2.5 grams. So you can calculate approximate masses. I'm going to ask some questions about potential and kinetic energy, so you'll need to know those masses. So you can estimate. Then I'll come in and I'll type in my heights. I dropped it from 12.5 centimeters, 25, 50, 100, oops, 150, and 190 centimeters. Now I have it set up where you can do 3 drops at each height. You don't have to do all 3. I only had time to do 1 drop at each height. You could potentially do 2. I think 3 might be overkill, but I put it in here. And then it's going to average your attempts. So here were my results. I got 40 millimeter crater, 42 millimeter crater, 44, 48, 49, and 50. Okay, and you'll see, so it averages for you. Again, you don't have to mess with the white cells. If you do like a second drop trial, and let's say it comes out to 42 the second time, then it'll average it. So you get 41 as your average diameter. So, okay, so anyways, I'm gonna go with just one drop for each height. And you can see what's going on here. I want you guys to look at it in Desmos, and you're going to quickly see that it's not a linear relationship. Okay, so this is called a power function, and it seems to oh, and I like how Desmos auto scales things now, so that's nice. But it's definitely not linear. It has this tapering off effect, so it's got some exponent in this function, and your job is going to be to find what that exponent is. And to do that, we do what's called linearization. And the way linearization works is we're going to take the natural log of both sides. I'll explain the math in just a second, but I want to show you how to do this in Desmos and in this spreadsheet. So by taking the natural log of both, the y variable and the x variable, which it's already done for you. So this value, if you care, it comes from taking the natural log of the height, and this one comes from taking the natural log of, uh, let's see, oh, the average diameter. Okay, so um, these values, when plotted, will give you a linear data set. And so I'm just gonna move it over to Desmos. There's something really cool about natural logs that do this. No, it's not going to be perfect. This is still experimental data, but it's going to help us identify the power law or the power function that describes this. So again, this is the natural log column and the natural log of my diameter. So natural log of height, natural log of diameter, and I'm going to do a regression. So in Desmos, to do regressions, the way you do this after you copy and paste that data is you come in here and you want to find a regression for y1. So I type in y1, and then many of you guys know this. I use the tilde key, okay, and then I say I know it's going to have some slope times my independent variable, which is x1, and I know it's going to have a b term, okay. And let me make this a little bigger. No, they changed it. There's no projector mode anymore. Oh no. Reverse contrast, but no projector mode. Oh, they took it away from me. So this slope that comes out, this turns out to be the exponent in our power law. So there's a really critical parameter, and then this intercept is a little bit less critical for us. So what I really want you guys to identify today is that power. And you're going to do this for um, experiment number one. So experiment number one is testing diameter of crater versus drop height. And then you're going to also come down and you're going to pick a constant drop height. So let's say, and I actually have done this test. I can kind of show you some of my results. I think I circled it. I tested 1 meter. You can make your choice. This might take, some decision making on your part. What height are you going to drop different masses from? So I started out with a 4.8 gram object, and then I did a 9.85 gram object and a 14.88 gram object and 19.88 grams. And those were all just different amounts of pennies in my egg. I recommend that you test for this second experiment. Test empty egg, test 5 pennies, 10 pennies, and 15 pennies. So 4 different masses. 0 pennies to 15 pennies gave pretty reliable results when I did it. And then I got average diameters of, let's see, I'll just type them in for drop 3. I got 40, 43, 47, and 48. Okay. Oh, and this should actually say, this is the natural log of the mass this time. Okay, so what we're going to check for is if this linearized data set, so these natural logs of the mass and the natural log of the diameter, produce a straight line. And if so, then we know that it's a power function. So if you want, actually I could do this. I'm going to just double check to see if this is linear in Desmos. So let me get rid of this. All right, so this again, mass versus or diameter of crater versus mass, you see this tapering off effect. And so this probably not very linear, but then when you look at the natural log of the data set, yeah, still not very linear. This might only because it's got 4 points. So we're just gonna go with it. But then again, to find the slope, okay, which would be the power function, you just look at y1 tilde m times x1 plus b, and we can see the slope of this one comes out to 0.134. Okay, and those will show up in the functions that we write. So I'm gonna stop this video and then record another one. But that's how you use this spreadsheet. Again, remember, just type in the yellow. Sorry, I accidentally deleted that. There you go. Type in the yellow, and you guys will do 2 sets of tests, right? This one you're varying height. This one you're varying mass, and hopefully they linearize nicely. And that's the point. Physicists and chemists and every scientist use this to help model certain data sets, and it's a really important technique. So it's one application of logarithms that we can really use and is useful to us. So all right, hopefully that gets you going.